One of my favorite parts of every spring is watching the March Madness tournament. In this tournament, you have 64 teams in a single elimination tournament. That means in order for a team to win, they can't lose until they are the only team remaining in the entire tournament. It's really fun and it's really exciting because there are so many upsets because everybody can lose once. But the question I've always had is, what is the probability of a team winning this entire tournament? And we call that compound probability because compound means two or more events. So we found in the last video how to find the probability of one individual event. This video is going to cover how to find the probability of more than one event simultaneously. By the end of this video, we're going to be able to answer my question. What is the probability of a team winning the entire March Madness tournament? Before we can get there, though, we need to talk about what independent and dependent events mean and the reason why they matter. Well, independent events, that if you're thinking about trying to be independent from your parents, that means that you are separated and you're on your own. So independent events do not impact each other. So when I think about a board like this where you're spinning a number and trying to hit it, if I hit a 3 on the first spin, I have a 33% chance approximately to get that. On the second roll, I still have a 33% chance, and on the third I would. So when something doesn't change between each roll, that makes it an independent event compared to each other. Also, if I would have 4 marbles like this, and if I pulled a marble and then I put the marble back in, each individual event would not impact each other. However, if I took out a white marble right away and I kept it, then we're dealing with what we call dependent events. And these events do impact each other. Because if I was looking for this first white marble, I have a 3 out of 4 chance to get it. However, when I go to pull the second white marble, I only have 3 marbles left. So now to find that, I would only have a 2 out of 3 chance to get it. So in that situation, we like to use the term with or without replacement is the word. So replacement means, do you put the object back? So for example, if I had a stack of cards like this, and if I pulled the blue card, if I put the card back in the deck, that's with replacement. If I keep the blue card out of the deck, that's without replacement. With replacement is almost always going to be independent events because the card goes back and you start over. If you do not replace the card, that would be a dependent event because it will change the total number that you are starting with. So let's look at one example from each of these types of problems. Let's start with the spinner. What is the probability of getting a 3 and then a 5? So this is an independent event, therefore the total number of each event will be 3, and I have to find the probability from there. So the first question is, what is the probability of getting a 3? Well, I look at my spinner, and these are all equal events to each other. There is 1 3 and 3 spots total, so I have a 1 in 3 chance of getting that number. Now, this is the whole trick with compound probability. In order to find the two events together, all I do is I multiply the probabilities of each. So the second event is finding a 5. So if I know the probability of getting a 3, I then look at the board. I have 1 5 out of 3 total, and I multiply them together. So if I have a 1 in 3 chance of getting a 3, and I have a 1 in 3 chance of getting a 5, getting both of them gives me a 1 in 9 chance, or 17% approximately. Now, the way I like to think of this is that if it is difficult to get one number, to get that same number again should be even more difficult. So when we are working with compound probabilities, your final probability will almost always be smaller than the probability of each individual event in the middle. The only time that that would not be true is if one of these events has a 100% chance of happening or a 0% chance of happening, but those are special cases. So on the second part of the problem, it's asking us, what is the chance of getting 3 threes in a row? Since this is an independent event, each 3 will have a chance of 1 in 3 because there are 3 spots total and there is 1 3. I simply multiply the probabilities together to get a 1 out of 27 chance. So if each of these are 33%, this final one is 1 out of 27. Now you see I wrote these all as fractions, but if you did these as decimals and multiplied them together, you would still get the answer. However, decimals make rounding a lot tougher. So if you have the choice, stay with fractions for as long as possible. Let's move on to a set with marbles, and we're saying that this is without replacement, meaning that these are going to be dependent events. So that means the marbles do not go back in after we pull one out. Okay, so for the first set, what is the probability of getting 2 whites in a row? So let's find the probability of getting the first white, and then we'll multiply it times the second. So if we look at our marbles, we have a total of 4. And 3 of those marbles are white. So that's the probability of the first. But since we got a white marble, we take one of those and we pretend that we pulled it out and it's gone forever. So now in the second probability, we only have 3 total marbles left. And we have 2 of them being white. Therefore, we simply multiply these 2 probabilities together. So this would be 6 out of 12. Which simplifies to 1/2 or 50%. If you were doing this as decimals, you would do 75% times about 67% would give you about 50%. And we notice once again that 50% is smaller than both of the individual probabilities we are working with because it is harder to do this twice, so your probability should be decreasing with each step. The next one is what is the probability of a white and then a brown marble? So let's erase what we did in the first part. The probability of getting a white marble, once again, will be 3/4. So then if we pulled a white marble out, maybe that time we got that one, so it's gone. Now the probability of getting a brown marble would be 1 out of 3 total. And once again, we multiply. We get 3/12, which is the same as 1/4, which is 25%. If we were doing this as decimals throughout the entire problem, this would be 75% times 33%. And that is equal to 25%. So once again, our percentages got smaller as we multiplied them together. For the final problem, it gets a little tricky, so we got to be careful in how we think of it. It says, what is the probability of getting 2 brown marbles in a row? So getting the probability of the first brown would be 25% because there's 1 brown marble out of 4 total marbles. So that is now gone. Well, now, to get the second brown marble, we have 0 brown marbles left out of a total of 3 marbles. Well, that's a bit of a problem. If we wrote this out as a fraction, we get 0 out of 12, which is 0%. Well, let's think about it. If there's only 1 brown marble, it should be impossible to get more than 1 of the brown marbles. So therefore, the probability of getting 2 in a row should be impossible, or 0%. So let's, after we've looked at that, let's go back to our original problem here, which is what is the probability of a team winning the entire March Madness tournament? So when we think about the March Madness tournament, there are 64 teams, okay? So teams that win their first game, that's going to eliminate half of the teams. So that drops us down to 32 teams. If you win your second game, that'll drop you to 16 teams. And this will continue on. We now have the Sweet 16, the Elite 8, the Final 4, and then the championship game. So if you won this game, that means you won your first game, your second game, your third game, your fourth game, your fifth game, and then you won your title game. So that means you won 6 consecutive games. But in each basketball game, you have 2 teams. You have Team A and you got Team B. Could be anybody. Let's say Team A is Syracuse. Go Big Orange. That's Coach Durfee's favorite team. And Team B, let's say this is Iowa State. That's Mr. Schmidt's favorite team. For the sake of argument, let's believe that these teams are equal. So that means that each of these teams has a 50-50 shot of winning this game, 50%. So then every game that each team plays should be 50%, or a 1 out of 2 chance of winning that game. So that's the chance of winning game 1. The chance of winning game 2, same, 50-50. And we're going to continue this on repeatedly. Game 3, game 4, game 5, and game 6. So this also could be 50% times 50% times 50% times 50% and so on. Well, in order to multiply these together, we end up getting 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So you have a 1 out of 64 chance of winning the tournament. You know, and actually thinking about it, that does feel pretty obvious, because if we remember, there were 64 teams in the tournament to begin with, so we have a 1 out of 64 chance of winning the tournament now, which is a little bit less than 2%.